Exchange reactions. Exchange reactions involve two compounds on both sides of the equation normally. The two compounds you're working with will be composed of positive and negative ions, and when we write compounds, the positive ion always comes first. The cation and an anion. They don't tend to be redox reactions. Not all of the reactions go to completion. Occasionally, one of the reactants could break down and you could have additional products. They can also be called double displacement, double replacement, or metathesis reactions. So an example of an exchange reaction is sodium bicarbonate and hydrochloric acid. Sodium bicarbonate, sodium is the positive ion, bicarbonate is the negative ion, and in hydrochloric acid we can look at hydrogen as the positive ion, chloride as the negative ion. When you do this reaction, sodium bicarbonate is baking soda, it's a solid. HCl is aqueous, it's an acid, it's actually a gas that dissolves in water. When you switch the ions, when you switch the partners, you'll get sodium chloride as one of your reactants or one of your products, and you'll get carbonic acid as another one. Now, one of the things that happens in this reaction is the carbonic acid is not stable and it breaks down to carbon dioxide plus water. So we have the exchange reaction followed by a decomposition reaction. Now this reaction will happen with any acid. In this case, this is something you can do at home. You can take sodium bicarbonate, which again is baking soda, and vinegar, and do this same reaction. Vinegar is about a 5% solution of acetic acid in water. Instead of sodium chloride, you will get sodium acetate as your salt. You will get carbonic acid, which should do the same thing, break down to form carbon dioxide plus water. You should also check the temperature, because you will see that this is an endothermic reaction, and you should see that it gets cold. And again, this reaction goes pretty fast. You're producing carbon dioxide gas, and one of the ways of testing for carbon dioxide gas is to bubble it through a solution of lime water, which is an aqueous solution of calcium oxide. And when you bubble carbon dioxide through this, you get calcium carbonate, which will form a cloudy solid solution. One of the reasons for the bicarbonate reaction going so quickly is the bicarbonate is very powdery, so what you have is a lot of surface area. You will see somewhere else on another slide where I have a reaction of zinc and hydrochloric acid. It's a different reaction, but the zinc particles are larger and the reaction goes a little bit slower. This bicarbonate reaction goes quickly and it's done very, very quickly. Again, here are our two reactions. Most endothermic reactions are not spontaneous reactions, but you'll notice when you put baking soda and vinegar together, it reacts immediately. This reaction is driven by entropy, which is what we call disorder. It's a fancy name for disorder.